Assalamualaikum warahmatullahi wabarakatuh and good day to viewers and judges. I'm Nuna Sulha Binti Kasim from Faculty of Applied Sciences, University Technology Mara, Polaris Branch, Arau Campus. With my team from UNIMAP, we'll introduce SDeTo, an effective pretreatment method to improve aromatic compound in biomass pyrolytic oil. To begin, I'd like to share with you the motivation of this study. In a global energy system, energy demand is rapidly growth due to the increasing in population in economic. Annually, primary energy consumption in 2018 shows 3 times increment compared to 15 years ago. This dramatic growth creates new challenges related to the energy such as energy shortage, energy efficiency, and crucial environmental issue. In addition, as the second largest palm oil producer in the world, Malaysia has produced abundance of biomass from oil palm industry. Therefore, development of green technology and environmental benefits using new alternative energy resources from biomass has been promising. The best technology in production of bioenergy such as bio-oil, biochar, biogas and chemical feedstock to replace fossil fuel, which is non-renewable energy due to biomass is low in sulfur content and suitable for the renewable energy power. As a Malaysian golden crop, Elias genensis species known as oil palm tree generated enormous quantity of oil palm waste. One of the waste is palm anti-fruit bunch. This is produced 1 ton from 5.8 ton of processing palm fresh fruit bunches. Major component of lignocellulose consists of hemicellulose, cellulose, and lignin, lead to the produce sustainable fuel energy. The production of biofuel is one of the world energy issues in attempt to implement the green energy technology. Second generation of biofuel is generated from non-food sources, including lignocellulosic biomass, agricultural waste, and dedicated energy crop through thermal, chemical, and biological conversion process. In order to get biofuel, thermochemical conversion using a catalyst is preferred. Catalytic pyrolysis is the efficient method for converting biomass into bio-oil on a large scale and capacity to convert up to 55% bio-oil yield in temperature between 300 to 550 degrees C. Do you agree with me that good quality of product begins with a good raw material? In this context, biomass pre-treatment must be done in order to upgrade the quality of the starting material to produce upgraded bio-oils. Therefore, the pre-treatment biomass of palm empty fruit bunch is a promising technique to produce an upgraded second generation of biofuel through thermal conversion of catalytic pyrolysis. Now, let's move to the problem statement that drive me to look more deeper on this study. As I mentioned earlier about the starting material, although palm empty fruit bunch can be converted to liquid bio-oil, however, poor properties of palm empty fruit bunch has downgraded the starting material with high moisture content, large amount of AAEMs, which is alkali and alkaline earth metal, that limit the development of palm empty fruit bunch thermal conversion. Large amount of AAEM in biomass initiate the second reaction that lead to the formation of solid biochar. As a result, low liquid bio-oil yield and poor quality of dark brown bio-oil product containing mixture of oxygenated organic compound that poor thermal unstable was generated from pyrolysis process. These 3 problems are the key to derive research question for this. I come out with the 2 objectives. The first is to produce a reduced inorganic species and increase carbon content of TDPEFB, which is torrefied demineralized palm empty fruit bunch, through sequential pre-treatment of demineralized and torrefaction process, which is SDeTo. And secondly, to enhance the quality of bio-oil by using cracking catalyst on catalytic thermal pyrolysis of torrefied demineralized palm empty fruit bunch. The first is the SDeTo, which is a sequential demineralization and torrefaction pre-treatment. that the product is a torrefied demineralized palm and tea fruit bunch. The second phase is the thermal conversion process, which is catalytic pyrolysis reaction in the presence of HZSM5 catalyst. And the last one, the characterization of the bio-oil. Next, objective 1 is successfully achieved to produce a reduced inorganic species and increase carbon content of TDPFB through sequential pretreatment or SDeTo. It can be seen that at TDPFB 240, the volatile increase. At this time, active decomposition of cellulose enhanced the depolymerization reaction into desirable hydrocarbon compound. However, successfully remove of the inorganic matter or AAEM as the ash content reduce that inhibit the secondary reaction. And also we can see that the oxygen OC and HC ratio reduce at this condition where the removal of moisture and volatile matter that contain oxygen and hydrogen through dehydration, decarboxylation, decarbonylation, and demethanylation. And the last one, we can observe that at TDPFB 240 degree C, it shows the reduction in oxygen content, increased carbon content, volatile matter, and calorific value. So this is the effect of SDeTo. Next, the few properties of TDPFB is able to hinder a drastic loss of mass and energy yield. So the less degradation of hemicellulose due to the removal of inorganic matter or AAEM that retarded the secondary reaction during the pyrolysis process. And the effect of this SDeTo pretreatment, where the mass and energy yield of TDPFB shows slightly higher than without demineralization associated with the trend of volatile matter. The energy density of TDPFB increase as the temperature increase. Thus, we can conclude that sequential pretreatment of or SDeTo offset the limitation of torrefaction pretreatment on a mass seal. And at TDPFB 240, selected as a solid biomass with properties of high carbon content, lower oxygen content, and acceptable ash content to produce upgraded bio-oil. Next, the effect of sequential pretreatment on pyrolysis product can be monitored or observed from these results. There are three factors that lead to the difference bio-oil yield. The first is the AAEMs or ash content, secondly is a lignocellulose component, and the third is alteration of chemical structure in the biomass. It can conclude that individual pretreatment of demineralized and torrefaction plays their own important role in the sequential pretreatment through reducing AAEM or inorganic matter and oxygen content respectively. For the GCMS analysis of bio-oil from the catalytic thermal pyrolysis of TDPFB shows that the phenolic and aromatic hydrocarbon compound has a great potential to be used as chemical precursor in the chemical, pharmaceutical, and polymer industry. And catalytic thermal pyrolysis of TDPFB increase in phenolic compound, aromatic hydrocarbon, and N-containing compounds to reduce in ester, organic acid, and carbonyl. The cracking and reduction process occur during the catalytic thermal pyrolysis. This can be explained using the reaction mechanism of catalytic thermal pyrolysis in TDPFB. There are two possible reaction pathways. The first is a phenolic pool and the second is hydrocarbon pool, which is dominant mechanism pathway in this reaction. So TDPFB consists of cellulose and lignin, where the cellulose will form active cellulose and will produce furan, and the end is a olefin, which is will produce a hydrocarbon pool, and this hydrocarbon pool will undergo the process aromatization to produce monoaromatic hydrocarbon. And secondly, the lignin will produce a small alkoxyphenol, which is produced phenolic pool, and will produce and with the monoaromatic hydrocarbon through a cracking and hydrogen transfer. As a conclusion, the reduced inorganic species and increase in carbon content for the pre-treated palm empty fruit bunch was successfully produced through sequential pretreatment or SDeTo. And secondly, the bio-oil produced from catalytic thermopyrolysis in the presence of the hexaSN5 increased in aromatic compounds which were responsible for catalytic cracking reactions such as cracking, hydrogen transfer, and aromatization. I can conclude that the novelty of this research, where the sequential demineralization and torrefaction, which is SDeTo pretreatment on palm empty fruit bunch PEFB, produced pyrolytic bio-oil enhanced the aromatic compound via catalytic pyrolysis using hexaSN5 cracking catalyst. Thank you.